everyone, today we're going to look at section 11.8, which is combinations. If you'll recall, in the last section we looked at permutations, and permutations are where order matters. When dealing with combinations, we don't care about the order. So a combination is a distinct group or set of objects without regard to their arrangement. In the first example, it says the Astronomy Club at Valencia College has members Joe, Carla, Opal, David, and Malcolm. Determine whether the description given below regarding a selection involving the Astronomy Club members describes a permutation or a combination. So it's very important to be able to determine the difference between both. If you're looking at the club selecting a president and a treasurer, would this be a permutation or a combination? You can pause the video and try answering this on your own, and then unpause when you're ready. So since selecting a president and a treasurer would involve votes, typically whoever received the most votes would be the president, and then whoever received the next number of votes would be the vice president if they had any, and so on. So order does matter here. So this would be a permutation. Of the 5 club members, 2 will be attending an environment club meeting together. So does it matter which 2? Would the order matter? You can pause the video and think about it and then answer on your own. So in this case, this will be a combination because it doesn't matter which 2 of the members out of the 5 are attending the club meeting. So since the order does not matter, we have a combination. Combination problems are solved slightly differently than permutation problems. So if you remember, for permutations, we had n choose r, and it's a permutation, and that just equaled n factorial over n minus r factorial. If you notice here in the combination formula, you're taking r objects and they're selected from n objects. So n would be your set and r would be your subset. So think of n as a larger set, and out of n you're taking r objects. And the way that we calculate combination formulas is n factorial over n minus r factorial times r factorial. So in this example, in your psychology class, you're assigned to read any 3 books from a list of 8 books. In how many ways can you select 3 of the 8 books to read? So think about why this is a combination and not a permutation. In this problem, it doesn't specify which 3 books or which specific order you need to read them in. So order does not matter here. So this is a combination. So to solve this, we're going to first figure out n, which is where r is coming from. So n is your set, which would be the 8 books, and we're selecting 3 out of the 8, so that's r. So we have a combination, and it's 8 choose 3. So n is 8, r is 3. And by the way, I'm going to put a little flag here. N will always be greater than r, just like it is in permutations. So this just equals, if I use the formula, it's going to be 8 factorial over 8 minus 3 factorial times 3 factorial. You can simplify this by writing it out, or you could use a calculator. I'm going to post some calculator videos for you all to refer to if you're using a graphing calculator, specifically the TI-84 Plus, which you can rent from the Learning Support Center. It will tell you how to use a graphing calculator to calculate combinations and also permutations. Also, a great app to use that's free is Desmos, and you can do combinations and permutations on there as well. So I'll also try to post a video helping you with that. Okay, so if I want to calculate this the long way, I'm going to first simplify the denominator. So I know 8 minus 3 is just 5, so that turns into 5 factorial, and then I have 3 factorial. Remember, factorial just means that number times all the numbers preceding it. So 8 factorial is just 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So a quick way to simplify this would be to stop when you reach this. So 8 times 7 times 6 times 5 factorial. Remember, 5 factorial just implies 5 times 4 times 3 times 2 times 1. So that takes care of the rest of the numerator. And now by doing that, you can cancel out the 5 factorials. And all you're left with on the top is 8 times 7 times 6, which is 336. And 3 factorial, remember, is not 3. It's 3 times 2 times 1. And that gives you 6. And 336 divided by 6 is 56. Okay, let me show you briefly, if I pull up Desmos, how we would do that. If I can find my Desmos app. Maybe I don't have it. There we go. Okay, so I'm going to do that same problem, but I'm going to do it on here. So you need to go to functions, and then you need to go all the way down to the bottom where it says number theory, and you'll see NPR and NCR. If we were dealing with permutations, you would pick the NPR button. We're dealing with combinations, so I'm going to pick the NCR button. And all you have to do is specify N and R. So in this case, N was 8, and then you're going to put a comma. The comma is right above the volume symbol, and then our R was 3. And as you can see, we get the same answer that we got when we worked it out the long way, which is 56. So if you don't have this app, get it, because you can do so many things with it. Okay, back to this. So the next one you guys can try on your own. You can pause the video and then unpause it when you're ready to go over this. Nick is the faculty advisor for the Brain Bowl team at UCF. For an upcoming tournament, Nick selects a team of 4 players from 6 eligible students. So how many different teams of 4 players are possible? Okay, does it matter which players are on the team? No. Does it matter what order they're in? Also no. So this is a combination problem. So to figure this out, I'm going to first figure out what N and R are. So N, remember, would be your set, so that would have to be 6, the larger set, and R is your subset. It's coming from N, so that would be 4. So now you have a combination, 6 choose 4, and that's equal to 6 factorial over 6 minus 4 factorial over 4, or times 4 factorial. And then I'm going to simplify this. So 6 minus 4 is 2. And then 6 factorial just means 6 times 5 times 4 times 3 times 2 times 1, which is just 4 factorial. And I'm going to cancel those out. 6 times 5 is 30. 2 factorial is just 2. And 30 divided by 2 is 15. After the tournament, Nick takes the team out for pizza. They order an extra large pizza and must choose 3 toppings from a list of 11 toppings. How many different 3 topping pizzas are possible? So again, it doesn't matter which toppings, the order doesn't matter, so I'm doing a combination. So N here would be 11 and R is 3. So I have 11 choose 3, and it's a combination. So it's 11 factorial over 11 minus 3 factorial times 3 factorial. And I'm going to cancel out the 8 factorials. And I would have 11 times 10 times 9. So that's 90 times 11. So that's 990 over 3 factorial, remember, is 3 times 2 times 1, which is 6. And then if I simplify that, 990 divided by 6 gives us 165. In our last example, at the Vera Asian restaurant, dinner consists of selecting 3 items from column A, selecting 4 items from column B, and selecting 3 items from column C from the menu. If columns A, B, and C have 5, 7, and 6 items respectively, how many different dinner combinations are possible? And the word respectively just means in that order. So first A would have 5, and B would have 7, and C would have 6. So that's all that means. Okay, so let's make a little chart. We've got column A, column B, and column C. And it says that column A has 5 items to choose from. So N would be 5. And column B has 7 items to choose from. And C has 6. And then we're selecting 4 items, or rather 3 items from column A, so R would be 3. We're selecting 4 from B, and we're selecting 3 from C. So does it matter what order we are selecting these in? And the answer is no. So these are all combinations, and they're going to be separate combinations. So here, this would be a combination of 5, choose 3. This would be 7, choose 4, and this would be 6, choose 3. And the fundamental counting principle tells us we're just going to multiply all of these together. So this would be a great problem to do on your calculator, but I'm going to work it out the long way. So I'm going to first look at the combination of 5, choose 3. So I'm going to use my formula. And then 7, choose 4. And then 6, choose 3. And I'm going to simplify. And then you can do this on your calculator if you want. I'm going to work it out. So I get 5 times 4 is 20, divided by 2 factorial. 20 divided by 2 is 10. 7 times 6 times 5. So 6 times 5 is 30. Times 6 is 210. And then I know I have 210 divided by 6. Remember, 3 factorial is 6. 210 divided by 6 is 35. And then 6 times 5 is 30, times 4 is 120. And I'm dividing by 3 factorial. Remember again, 3 factorial is 6. 120 divided by 6 gives me 20. So then if I multiply 10 times 35 times 20, that would give me 7,000. So there's 7,000 different ways to choose food from the dinner menu. Okay, that wraps up 11.8, which is the last section that's on your test. Below, I gave you a kind of a summary of the counting principle and how it's related to permutations and combinations. Just remember that permutations, the order is important, and for combinations, order is not important. So they're the two things that you want to keep in mind when you're doing these problems. Okay, if you have any questions, please let me know. Email me or set up time during my office hours, and good luck on your test.